I think we've actually gotten to a point now where we're ready to look at this full circuit. We've already looked at this half of the circuit, obviously with a few small changes, that being a switch and a few other component changes, but the actual circuit is almost identical. So we know what's happening through most of this circuit. Now it's time to look at this. So we have two transistors here, both being used as switches. A switch here and a switch here. So this is, instead of a momentary switch now, these two are going to trigger one another. And they're going to alternate between on and off, each of them. A few things to know about this circuit and why it breaks into a self-sustaining oscillation. If all the components you see in this diagram, if all of them were exact, are perfect components down to the nanoparticle, and there was no variance whatsoever in it, this circuit wouldn't work. You'd turn it on, you apply your power, and both of these transistors would saturate at the same time, and it would not break into a self-sustained oscillation. Because of the component variables, one of these transistors is going to saturate first. And that's all we need for this thing to break into a self-sustained oscillation. If one of them saturates first, it will start triggering a chain of events. What happens now when we power this up? So imagine we've got our switch here, which I really should have drawn into this by now. We close our switch. So for argument's sake, let's say Q1 saturates first. We know one of them is going to saturate first. We actually don't know which one. But let's say for argument's sake, Q1 saturates first. So Q1's on, Q2 is off. Power comes down here, saturates Q1. Power flows down here, lights up LED 1. This capacitor, the positive plate of this cap, is now at the most negative point of this circuit, which is the negative of the battery. Negative of the battery. And this is now connected to it. Imagine a straight bit of wire across that. Power tries to flow down here. But this capacitor is now reverse polarity. And as we know, it is going to start to take on a little bit of charge in the opposite direction. But what it's going to do is, it's not going to do that straight away because the current flow is being restricted by this resistor. So the cap is discharged. Both of the caps start discharged. But this cap is discharged. So what it's going to do, power is going to come down here and it's going to start filling it up. So it's only going to fill it to 0.7 of a volt in the opposite direction, like as a reverse charge. But it's going to start filling this cap up to 0.7 of a volt. So on this side of the plate, there'll be 0.7. It'll be start from 0, start to rise to 0.7 of a volt. That's what's holding this transistor off, because it's starting at 0. So for this transistor to turn on, we need a base to emitter voltage of about 0.7 volts or above. So it's going to flow down to here and it's going to start filling this. And it's not until this gets to 0.7 of a volt that this turns on. So there's a slight delay there. And that's kind of crucial to how this circuit works when you first turn it on. And then what happens then? So power comes down here. This is off, so it can't keep going through here. So it comes down here and it starts filling up this cap. So this was, imagine this LED, when we first power this up, is going to glow until this cap is full. Same as what it did in our previous experiment with this circuit here. It was this one here, but same principle. Power comes down here and it starts filling this capacitor. So to recap that, switch on, power down here, this transistor saturates, this LED lights up, it reverse polarities this capacitor. This capacitor starts filling up from 0. This transistor won't turn on until this voltage is risen to 0.7. In that time, power is flowing down here, through here, and filling up this capacitor. Two crucial things have to happen to this circuit when we first apply power to it for it to break into a self-sustained oscillation. So as we discussed, one of these transistors has to saturate and turn on, which we know it does and we know why. And the other thing, let's say for argument's sake, as we said, Q1 saturates first. This capacitor also needs to be able to take on that reverse charge, because if it doesn't, let's say if that couldn't take on the reverse charge, then there'd be no time delay when we power it up, and not only would that one saturate, so would this one. They both saturate at the same time, which would, both the LEDs would light up at the same time. It wouldn't break into a self-sustained oscillation. So that little time delay there is crucial for the circuit to stabilize into its astable state. We're now at the point where this has risen from 0, so we've turned it on, and this has risen from 0 up to its 0.7 of a volt, which means this is now hit its saturation voltage. So Q2 is going to turn on. It's going to change state, both that capacitor and that capacitor. The circuit's going to change state. This is now going to light up. LED 2 is going to now light up. And what it's going to do over here is it's going to put the positive plate of C1 to the negative. So it's going to come from here all the way around through our closed transistor. So this point now looks at the most negative. And what's going to happen is this cap's now going to start discharging, because this cap was fully charged. And while that's discharging, it's going to try and equalize. So it's pulling current down from here into its negative plate. So this looks like a negative to the base of this transistor. So while this is at the negative, this transistor is in its cutoff state. So it'll keep looking like a negative to this until it goes to a 0, till it completely discharges. And then this will look like a 0, and then this will start to take on a reverse charge. So this will start to climb up to 0.7 of a volt. So while this is on, LED 2 will glow. But what will happen with this capacitor, because this is now off, it's now in its cutoff, while this is discharging, briefly, as we saw, this cap will charge. So power will be flowing down here, and it'll light up this LED briefly until this capacitor charges. And this cap will charge to 6.8 volts. So, and that'll all happen until this rises to 0.7 again. When this rises to 0.7 of a volt, it'll saturate again. So this will then turn on. This LED will turn on, and it will pull the positive of this capacitor to the negative. So this cap was charged again. So what's going to happen to this? It's now got a discharge. So this capacitor around here is now discharging. So it will look like a negative to the base of this transistor, which means this transistor will be in its cutoff region. This will glow briefly while this capacitor is now charging. Q2 will stay like that. It'll stay in its cutoff region until this capacitor is completely discharged, and then it goes from 0 and rises to 0.7 again. When that happens, it'll saturate, and then the cycle will repeat itself. So when Q2 saturates, it then pulls the plate of this cap's now charged again, it pulls the plate of this back to the negative. So this cap now has to discharge. Once again, it's equalizing, coming down here, through here. So this looks like negative 6.8 volts to the base of this transistor. This transistor is in its cutoff. While this transistor is in its cutoff, this cap will charge. This LED will stay lit up briefly while this cap charges, while this one's on. This one will stay cut off until this is completely discharged, and then starts rising from 0 back to 0.7 again. That is the cycle. Here we have our circuit fully functional. I'm only scoping one half of the circuit because that's what we're used to seeing. And if I was to scope all 4 channels, if I was to use all 4 channels on the scope and scope both halves of the circuit, this screen would just be an absolute jumbled mess. So this is what we're used to seeing. So this is why I've set the scope up how I have. But it's just scrolling through now, and the circuit is flipping from one state to another. You'll notice with these LEDs that there's a little bit of hang time. And by that I mean when one switches on, the other one hangs on for a tiny little bit, and vice versa. We've already spoken about why that is, and that's because of this capacitor charging. We will go back to the schematic and have a look at that in a minute, and I'll explain that a little bit better. And there's a way of fixing that, and we're going to do it. It's very, very easy. The other thing I've noticed, which I'll point out, is there's a little bit, when this transistor's turning on, they turn on abruptly, so there is a tiny little notch here. So it's rising up, it goes through at 0, and then it has this little notch. I'm not going to talk too much, well, I'm not going to talk at all about that. It's to do with how the transistor is abruptly turning on. But what I do want to show is how this cap is charging. You'll see if I turn that trace off, you'll notice the cap's just charging nicely. And that was what we expected. To fix our circuit, to stop the hang time from happening, all we need to do is we shift this connection, so the positive plate of C2, up onto the other side of the LED. So as you see in this drawing, so we do that for both of them. And what will happen is, when this capacitor, or this one, is charging, as they're charging, instead of charging down through the LED into the capacitor, they're charging through the resistor straight into the capacitor. So when either of these turn off, with it in this position, these will still charge, but they won't be charging down through the LED. So that'll stop that tiny little bit of hang time. When each of these transistors switch off in their sequential order, the LED will switch off abruptly with it. And it's that simple. And here is our final circuit. And here is it running. So as we can see, it definitely works. I've made these changes here, which corrects the hang time. The only thing is, these are not 47K. These are 10K. That one and that one. Just to speed it up a little bit. To change the speed on this circuit for either of these LEDs, you can either change this resistor, or these two resistors, sorry, or these two caps, or both. But I'll let you play with that if you want to build it. But if you build it exactly how it is now, it will work. And then you can start playing around with your resistors and caps to see what it does. But baseline, if you want to start somewhere and you want it to work, I have built this. You can see it there. It definitely does work.